Hey, sixth graders, it's time to run your experiments. Before you do, I'm going to model for you how to set up this experiment and give you a sense of what you're going to be doing. So, the question you're trying to answer is, how does carbon dioxide in the atmosphere affect temperature? We want to run an experiment on that and answer that question. So how are we going to do that in this classroom? Obviously, we can't use the entire globe, the entire Earth to answer that question right now. So instead, we're going to use a model of the Earth and run the experiment that way. And we'll do the test on our model and then use that to figure out what's happening in the bigger world. And to make a model of the Earth, we're going to use a 2-liter soda bottle. This actually works really well as a model for the Earth. Now, no model is perfect, obviously. It's not exactly like the Earth, but it's close enough that it will allow us to answer our question. So how do we make a model of the Earth with this bottle? Well, you got to remember that most of the Earth is covered by water. So, to start, I'm going to pour some water inside the bottle. I've decided to use 250 milliliters of water for this experiment. You can use more. It's really up to your team to decide how much water you want to use. So I'm going to go ahead and pour that into the bottle. You can see, before I do, you can see that I've taken the bottle and I've very carefully cut around the top about 3/4 of the way up, cut around the top. I left a little bit attached here, so it just flaps open. When you do that cut, do it very carefully. Try to keep it nice and even and smooth. All right, I'm going to pour in my water. Now, obviously, the Earth also has like rocks and dirt and animals and plants and stuff like that. But for this experiment, we're not going to worry about that. We're going to say that adding water, since that covers most of the Earth, is going to make this a good enough model of the Earth for our experiment. All right, so here's kind of my model of the Earth. Now we want to measure temperature. We're going to see how the temperature is affected inside the bottle. So to do that, we got to get a thermometer inside the bottle. So I'm going to take one of these thermometers and tape it on the inside of the bottle. Now before I do, I'm going to point out one thing. You'll notice that these thermometers, they work well, but they're a little cheap. So the bulb can slide up and down a lot. Now you want to make sure that it's set up correctly. So make sure the top of the thermometer is lined up with this little line in between the C and the F. So I'm going to put that up here just a little bit. Perfect. You got to do that really carefully because that's a really important thing for taking accurate measurements. All right, so now I'm going to go ahead and tape this inside my bottle. I'll just take a piece of tape here. Put it like that. Now, when you do this, make sure the thermometer is facing out so you can actually see it during the experiment. Tape it to the top. And there we go. Now we got a thermometer inside our bottle that's going to allow us to measure the temperature. Really, really important. You want to be measuring the temperature of the air inside the bottle. So make sure that the bottom of the thermometer is not in the water. You want to make sure the bottom of the thermometer is in the air because the bottom is where the temperature actually gets measured. So I got, yep, the bottom of my thermometer is in the air. It's not in the water, so that's good. So now I'm going to go ahead and seal this up. I'm going to do this really quickly because I'm just demonstrating for you. When you seal up your bottle, take your time and do it really well. You do not want any air to escape the bottle. In fact, I recommend using better tape, like maybe the duct tape, to seal up the bottle when you do this part, because it will seal it up a lot better. Okay. So here's my model of the Earth. I got water to represent the ocean. The air inside the bottle represents the Earth's atmosphere. And I got a thermometer in there that's going to allow me to measure the temperature. So, I'm going to now, hang on one second. We wanted to see how carbon dioxide affects the temperature, right? So to do that, we got to get some extra carbon dioxide in our model. Now, we have a really easy way of making carbon dioxide. Alka-Seltzer. Alka-Seltzer is a chemical that when it touches water, releases carbon dioxide. That's why when you drop Alka-Seltzer into water, you see all those bubbles and fizzing. That's carbon dioxide being released. No, but wait. Let's think about this for a second. I want to see how carbon dioxide affects the temperature inside the bottle. So, okay, I put in the Alka-Seltzer, it's going to release carbon dioxide, and I can measure the temperature in there. But how am I going to know if it's any different? How am I going to know that the carbon dioxide had an effect? Pause the video for a second and talk with your team about how you're going to know for sure if the carbon dioxide affected the temperature. What could you do to know for sure? All right, welcome back. So, hopefully what you talked about is that to know if the carbon dioxide affected the temperature, you've got to have something to compare this to. You've got to be able to compare this to a situation where there isn't extra carbon dioxide. Because that way you'll know for sure if adding the carbon dioxide affected the temperature. So to do that, you need a second bottle. This bottle, you can see I've already set it up, is going to be set up exactly the same as the first bottle. The only difference is that this bottle will not have extra carbon dioxide. This bottle will have extra air. Talk to your table real quick. Pause this video and talk to your table. Why is it important that the only difference between these two bottles is the extra carbon dioxide in this bottle? Hey, welcome back. So hopefully what you talked about is that if the temperature changes in this bottle and not this one, or if this one changes more, I want to know for sure it was because of the carbon dioxide. Let's say I had extra water in this bottle and extra carbon dioxide. Well, if the temperature change is different and I had two differences, I'm not going to know, is the temperature different because of the carbon dioxide? Is it different because of the extra water? I only want one difference, because then if the temperature is different here, I know it was because of the carbon dioxide. So I've got two bottles. Right now they're exactly the same. In a little bit, I'll put in the Alka-Seltzer into my first bottle so I know that this one's going to have extra carbon dioxide. Now, if we're modeling this like the Earth, we know that the thing that heats up the Earth is the sun. So this light bulb here, I'm going to tape it down a little bit more to hold it up, is going to represent the sun. And what I'm going to do for this experiment is I'm going to turn on the light bulb, and I'm going to sit these two bottles in front of the light bulb for a certain amount of time and measure the temperature. Every minute I'll measure the temperature and see what the temperatures are in the two bottles. And we'll see if there's a difference in the bottle with extra carbon dioxide. Now, like I said, I only want one difference between these two bottles. So you notice that they're the same color, they've got the same amount of water, they've got the same type of thermometer. I'm also going to make sure that they're both the same distance from the light bulb, because I don't want that to make a difference between the two. So, okay, I'm going to use my ruler here to measure the difference. Good. So now I've got the two bottles. They're both, a little bit closer. They're both the same distance from the light bulb. All right. Now, the last thing I have to do before I turn on the light bulb is add the extra carbon dioxide. I'm going to drop in both Alka-Seltzer tablets into the bottle to make that happen. You should have two people do this together, because as soon as you drop in the Alka-Seltzer, you want to close up the top as fast as possible to trap all of that extra carbon dioxide. You're going to have to break these in half in order to fit them into the top of the bottle. Here we go. Seal it up, and you can already see the fizzing has begun. The carbon dioxide is being released into the atmosphere. Now, I recommend letting this finish, let the bubbling finish so you get all of the carbon dioxide out. And once all of the carbon dioxide is out, you should start your experiment. And it's very simple. Make sure the thermometers are facing away from the light bulb. Do not have the thermometers facing towards the light bulb. Turn them away from the light bulb. Turn on your lamp. And as soon as you turn on your lamp, start your timer. And every minute, measure the temperature in both bottles and record them in your data table. And that's how you run your experiment. So now go talk to your teachers if you have any questions. And if not, go ahead and go back to your worksheet for this step and work on your experiment.